Treat the plug as a new electrical service. Install a main distribution panel at the event location. Run the two hot conductors labeled L1 and L2 from the plug into the main distribution panel. Connect the neutral conductor labeled N from the plug to the neutral busbar in the main distribution panel. Connect the ground conductor labeled G from the plug to the ground busbar in the main distribution panel. Do not bond the neutral and ground conductors in the main distribution panel. This is a 3-wire, single-phase system, and the neutral should not be bonded to the ground. Do not drive a ground rod. The ground conductor from the plug provides the path to ground. If you lose the ground connection, the following could happen. Firstly, the equipment will continue to operate, but it may be more susceptible to electrical faults. Secondly, the ground fault circuit interrupters, or GFCIs, and the 120-volt loads may trip, cutting power to those loads. Thirdly, if there is a fault in the equipment, the fault current may seek a path through the 120-volt loads, creating a potential shock hazard. It is recommended that you use a commercial-grade extension cord with a 3-prong plug to connect the equipment to the Fairground outlet. Test the ground connection regularly to ensure it is intact. Consider installing a ground fault circuit interrupter, or GFCI, outlet at the main distribution panel to protect the 120-volt loads from ground faults. Understanding these principles is crucial for setting up a safe and reliable power distribution system at your event. Remember to always prioritize safety and consult with a qualified electrician if you have any doubts or concerns about your setup. The Fairground provides a 240-volt single-phase power supply, typically with 2 hot conductors and a ground. Your equipment consists of both 240-volt and 120-volt loads, all protected by breakers in the main distribution panel. Upon arrival at the Fairground, you encounter 240-volt outlets with a 30-amp, 3-wire configuration. These outlets serve as your power source, essentially a new electrical service point. From this point, you will establish your power distribution system to safely operate your equipment. Wiring the main distribution panel involves several critical steps. Firstly, connect the 2 hot conductors, often labeled as L1 and L2, from the Fairground outlet to the corresponding terminals in your main distribution panel. These hot conductors carry the 240 volts electricity that will power your equipment. Secondly, connect the neutral conductor from the Fairground outlet to the neutral busbar within your main distribution panel. The neutral busbar serves as the return path for current in your 120-volt circuits. Thirdly, connect the ground conductor from the Fairground outlet to the ground busbar in your main distribution panel. The ground busbar provides a safety path for fault currents, helping to prevent electrical shocks. Bonding the neutral and ground is a practice that needs very careful consideration. In this scenario, it is crucial that you do not bond the neutral and ground conductors in your main distribution panel. The Fairground provides a 3-wire, single-phase system, meaning the neutral and ground are kept separate at the source. Bonding them in your panel would create a parallel path for neutral current, leading to potential safety hazards and equipment malfunction. Grounding is another critical aspect of electrical safety. In this setup, you should not drive a ground rod. The ground conductor from the Fairground outlet already provides a sufficient path to ground. This ground connection ensures that any fault currents can safely flow back to the source, trapping breakers and preventing electrical shocks. Losing the ground connection can lead to dangerous situations. If the ground connection is lost, your equipment will continue to operate, but it becomes significantly more vulnerable to electrical faults. Without a proper ground, fault currents may seek alternative paths, such as through the metal enclosures of your equipment or even through people, posing serious shock hazard. Furthermore, the ground fault circuit interrupters, or GFCIs, on your 120-volt loads may trip if the ground connection is lost. GFCIs are designed to detect even small imbalances in current, and they will quickly cut power to prevent electrical shocks. However, if the ground is lost, they may not function properly, leaving your equipment and personnel unprotected. If a fault occurs in your equipment, the fault current may attempt to flow through the 120-volt loads, potentially creating a 240-volt situation on those circuits. This can damage your 120-volt equipment and create a severe shock hazard. To mitigate these risks, several recommendations should be followed. Firstly, always use a commercial-grade extension cord with a 3-prong plug to connect your equipment to the Fairground outlet. A heavy-duty cord will ensure a reliable and safe connection. Secondly, regularly test the ground connection to ensure it is intact. You can use a simple continuity tester to verify that the ground conductor is properly connected. Thirdly, consider installing a ground fault circuit interrupter, or GFCI, outlet at your main distribution panel to protect the 120-volt loads from ground faults. A GFCI outlet will provide an additional layer of protection, quickly cutting power in the event of a ground fault. In summary, when setting up power at an event using a Fairground's 240-volt single-phase service, remember to treat the outlet as a new electrical service. Properly wire the main distribution panel, ensuring that the hot, neutral, and ground conductors are connected to their respective bus bars. Do not bond the neutral and ground conductors in the panel, and do not drive a ground rod. Regularly test the ground connection and consider installing a GFCI outlet for added protection. By following these guidelines, you can ensure a safe and reliable power distribution system for your event. 240-volt supply you are tapping into at the Fairground is essentially a service entrance and must be treated with the same caution. The primary service is grounded back at the transformer that supplies the Fairground. The 3 wires at the plug, 2 hots and a ground, provide the path for electricity to flow to your equipment and a safety path back to the source in case of a fault. Here's a breakdown of why the recommendations are what they are. Firstly, the 2 hot wires, LON and L2, deliver the 240 volts power. You'll connect these to the main lugs or breaker in your distribution panel. These are your source of power and need to be correctly connected to distribute power to your 240 volt and 120 volt circuits. Secondly, the neutral wire, also known as the identified conductor, is crucial for the 120 volt circuits. It provides the return path for current, creating a complete circuit. It's important to connect this correctly to the neutral busbar in your distribution panel. Thirdly, the ground wire, also called the equipment grounding conductor, is solely for safety. It's designed to carry fault current back to the source, tripping the breaker and preventing electric shock. This should be connected to the ground busbar. Now let's clarify why you shouldn't bond the neutral and ground at your distribution panel. The neutral and ground are already bonded at the main service entrance, likely at the transformer supplying the Fairground or in the main panel for the Fairground itself. Bonding them again at your distribution panel creates a parallel path for neutral current. This can cause several problems. 1. It can cause current to flow through the ground wire under normal conditions, which is not its intended purpose. 2. It can interfere with the proper operation of ground fault circuit interrupters, or GFCIs, and other safety devices. 3. It can create a potential shock hazard if the ground wire becomes disconnected. Similarly, driving a ground rod is not necessary and can actually be detrimental in this situation. The ground wire from the Fairground outlet already provides a low impedance path to ground, which is what you want for safety. Driving a ground rod may not provide a better ground, and it can create a difference in potential between your ground rod and the Fairground's grounding system, which can cause problems. Understanding what happens if you lose the ground connection is crucial. Without the ground connection, any fault current will have no safe path back to the source. This means that metal parts of your equipment could become energized, posing a serious shock hazard. A ground fault circuit interrupter, or GFCI, is a device that protects against electric shock by monitoring the current flowing through a circuit. If it detects an imbalance, indicating that current is leaking to ground, it will quickly trip the circuit. If you lose the ground connection, the ground fault circuit interrupter, or GFCI, may not be able to detect a ground fault, leaving you unprotected. In addition, you could potentially backfeed 240 volts onto your 120 volt circuits. This could happen if there's a fault in your equipment or wiring. It's a dangerous situation that could damage equipment and create a significant shock hazard. Therefore, regular ground testing is critical. Using a commercial-grade extension cord is important because it is designed to handle the amperage and voltage requirements. Cheaper cords might not be properly insulated or have sufficient wire gauge, leading to overheating and potential fire hazards. Consider installing a ground fault circuit interrupter or GFCI outlet at your main distribution panel to protect the 120-volt loads from ground faults. A ground fault circuit interrupter or GFCI is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault. It works by comparing the amount of current going to and returning from equipment along the circuit conductors. If there is a difference of more than 5 milliamps, the ground fault circuit interrupter or GFCI trips, interrupting the current flow. This protects you from dangerous electrical shocks. In summary, treat the Fairground outlet as a new electrical service. Wire your distribution panel correctly. Do not bond the neutral and ground. Do not drive a ground rod, and take precautions to protect against loss of ground. These steps will help you set up a safe and reliable power system for your event.